Hey everybody. Good evening, everyone. Let's start the session now. We have waited long enough. So, today's session is going to be about neural networks. For those of you who have joined freshly today, like for those of you who have not attended yesterday's session, let me give you guys a brief about what yesterday's session was. So basically, this first of all, this is a program from Google AI and Google Crowdsource. The Explore ML program aims to inculcate and build an intuition of machine learning to the new people moving in the technology industry. So basically, the aim is to get more and more students motivated towards the field of machine learning and artificial intelligence. Yesterday's session was basically a bit of an introductory session towards machine learning, like what machine learning was, what are its types, what are its use cases, what types of problems can we use machine learning to solve, etc. Today's session will be a bit more advanced, but not to overwhelm you. Basically, today's session will be a lot more interactive than yesterday's session because yesterday we covered a lot of theory and you guys got to know something about machine learning. But today we'll be doing a hands-on practice. Basically, you guys will be training a neural network from scratch without writing a single line of code. So let's dive right into today's session. So as I mentioned, today's session is going to be on neural networks. Neural networks are basically used in the field of machine learning, and as we saw yesterday, deep learning is a special type of machine learning. Like it is a subset of machine learning which is used to solve even more complex tasks. So before going right into the session, I would like to ask you guys a few questions for everyone who attended yesterday's session. Can anybody briefly answer what is machine learning? Anyone? Come on, guys! There are 52 people here, and I think most of you guys attended yesterday's session. See, there are no right or wrong answers here. Whatever comes to your mind, just speak up.
So basically, machine learning is like when you give the computer data set and it just reads the data set and solves the problems that are coming according to the given data set, like without a specific instructions on what to do. Like it analyzes all the data by itself and create differences.
Yeah, right. As Nikhil said. Yeah, Divyansh, go ahead.
So machine learning is basically it means focuses on the uses of data and algorithms and create or do the activity which humans want to perform. That's what ML and AI refers to, according to me.
Yeah. So both of you guys are pretty much right. So ML has enabled us to solve problems which were not easy to solve, or basically which we didn't have the tools to solve a few decades back. Some of the complex problems like image recognition and NLP related problems, text related problems, computer vision, etc. Other than that, we saw multiple types of machine learning algorithms yesterday, like regression, classification, clustering, and their individual use cases, when to use which one. So now let's dive into today's session. We'll be starting off with a video now, and after that, I will be asking you guys about your thoughts. What do you think, like about machine learning, and you will get a better insight from this video. Is the audio audible?
Yes, sir.
Okay, thanks. Just a second. I think you guys, can you guys see my screen?
No, sir.
No, sir.
Okay, just a second. I share. Okay, now can you guys see my screen?
Yes, sir.
Just a second. Let me start the video.
Hi, I'm Nat.
Is the video audible?
Yes, sir.
Yes.
Okay.
Hello. And this is our 20% project, where we go find out about different Google stuff we're curious about. Last year, we got to make a documentary about how voice search works. And that was the first time we heard about something called machine learning. Since then, we've been kind of fascinated by it. So today, we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it, but for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters. When you go to the ATM and you give a check and it can read the handwriting. Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos, here are all my dog photos, here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. Ooh, ooh. So researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn. But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog. So it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything it can classify as? And suddenly you can go and ask, neural net, what do you think cat looks like? And you get a picture of a cat. Or, neural net, what do you think a barbell looks like? So these weights. And it goes and it shows you a picture not only of a barbell, but of an arm attached to a barbell. So the model thought that the arms, it only learned what barbells were from looking at pictures of barbells, and they're often held by muscular weightlifters. And so it learned that there was, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, you say to a kid, that's a filing cabinet. And then a second later you say, what's that? Yeah. He's not going to be like, shoe, right?
Well, like, the more you describe this, the more I'm amazed by human beings.
Yeah.
The effect is like, wow, human beings are really amazing.
We're really amazing learning machines.
Okay, so I think this video might have given you a bit of insight how deep learning works, how these complex algorithms solve some of the most difficult problems which we can't solve, right? So before we move forward, let me ask you guys, after seeing this video, any one of you, please explain, what do you think, what is a neural network? What is your definition of a neural network? Anything, whatever comes to your mind. I'm not judging you. This is not a lecture or something. See, I want this to be a two-way conversation, as I told in yesterday's session as well. So the more you discuss, the more you will learn. Okay, and I will also get to know how much you have learned or how much you are getting what I'm teaching. So anyone who wants to speak, please raise your hands, and then I'll give you a chance. Anything, whatever comes to your mind. Yeah, Dhriti, go ahead.
As in this neural networks, we kind of make the computer, we teach the computer to learn what the things are by feeding them different information on the basis of complex mathematical calculations. Just like humans, we tell humans this is a cat, this is a dog. Computers don't get that, so we make certain algorithms and calculations to tell them that if this looks like this or it has the same algorithm, then you would call it a dog. At least like the maximum probability, which is at 92.4, so it has to be a dog.
Yeah, Dhriti, that's a very great answer. Anyone else would like to suggest their definition of a neural network? Okay, so let's move forward. So basically, as this video also showcased, when we create a deep learning neural network, so it consists of multiple smaller building blocks, which are called as neurons. We'll get to what a neuron is in after a few slides. But basically, there are very small building blocks in a neural network, which extract very small amount of information from the problem what they're trying to solve. For example, as the video showed, for example, we want to make a model that checks or predicts if a dog is present in an image. So maybe a very small part of that neural network can find if there is an ear, if a nose is present, and then all of those small building blocks can combine very small amount of information to combine that information to predict if a dog is present or not. So let me move to the next slide, and you will get a better idea. Yeah. So suppose this image demonstrates a neural network. Suppose we are building a neural network to differentiate between cats and dogs. First of all, as you can see my mouse pointer, right? Please confirm.
Yes, sir.
I'm hovering over this point. Yeah. So these small black dots you are seeing, these are basically, I would suggest, very small machine learning models. Let me get you just a second. So basically,
मोहन
if we
माउस
talk
पॉइंटर
about,
चेंज कर ले यार.
sorry,
माउस पॉइंटर है ना,
yeah,
वो अगर हो सके तो चेंज कर ले.
um,
व्हाइट के ऊपर व्हाइट दिख नहीं रहा है.
just a second. I think this would be better, right? You can see this laser pointer, right?
Yes,
Yes.
sir. Yes.
Okay.
साइज इंक्रीज हो सकता है क्या इसका?
I don't think so. I don't think so. So basically, in yesterday's session, we learned a few types of machine learning algorithms like regression, classification, clustering, and they were solving some particular problem, right? If we needed our output to be continuous, then we used regression. If we knew that our output would be divided into discrete classes, then we use classification, and like so. So, but the thing is, for example, in linear regression, what we do, we draw a line that separates two kind. If we are building a binary classifier, or basically if we have only two types of data, and we are using suppose we are doing a classification problem, and we the model draws a line between those two classes that separates all the points above this particular line belongs to class A. All the points below that particular line belongs to class B. So we can use those machine learning algorithms to solve some simple problems. Although those problems are not simple, but when compared to the kind of problems which deep learning or neural networks can solve, they are those kind of problems are particularly simpler. So now let's come to the problem at hand. Suppose if we want to build this cat versus dog classifier, right? A simple line cannot tell if the image contains a simple classifying line cannot predict if an image contains a cat or dog, because here our problem has become more and more complex. There are so many data points. An image consists of multiple pixels, and each pixel has some different information. So as the size of data is growing, as the complexity of our problem is growing, we also need to grow the complexity of our model. So that's where neural network and deep learning comes into action. So as I was telling, these single black dots, each black dot represents a very small machine learning model called as a neuron. I will tell you what is a neuron, how it works in further slides. But here, just think this is a single entity which makes a decision. Okay. So we combine those multiple entities together in a layer. So this is our first layer, which is the first layer is always known as the input layer. It takes the input. Then the further layers are called output hidden layers. Like the last layer is known as output layer, and all the layers between the input layer and output layer are known as hidden layers. So this second layer and third layer here are known as hidden layers because they are known as hidden layers because we don't know what's going on inside them. We just set the parameters for those layers, but we need the inputs, what are the output parameters, and some extra hyper parameters like activation function, loss function. I will get to them in a second. But so that is the reason they are known as hidden layers, because we don't know what kind of calculations or what features are getting extracted in those layers. So all the layers between input and output layer are known as hidden layers. So now the thing is, let's take this particular point, this corner one, right? So what this is doing, when I feed an image of a cat or any particular image into this input layer, this single point or this single model, this single entity is what it's going to do is it's going to find just a simple thing. Like for example, this can find basically if an ear is present or not, or if eyes are present or not, like so. then this particular point here can find something else. Maybe that point doesn't know if the input contains year. That doesn't know if it is a year or no. They simply get data in zeros and ones format. So basically, what I'm trying to say here is a single entity, a single neuron. What it does is it takes very small, it extracts very small amount of information from the input data, and then all of these neurons combined provide a much larger extracted information from the image. So for example, suppose I have 100 neurons in this first layer, input layer, then those 100 neurons will, each of one will extract very small amount of information from that image, combine them, and then that information will be passed on to the next hidden layer. So that is how deep learning or neural networks work. Each neuron finds something very small amount of information. Then in the next layer, there are some more neurons. That neuron may find some other information. In the next layer, there are more neurons that might find something else. And then combining all of that extracted information will give us the result. For example, suppose I reach the last layer, that is the output layer, and after looking at the input image, whatever we have provided, and after looking at all the extracted features from those layers, it basically does the prediction, like if it is a dog or a cat. So this is how a neural network or a deep learning model works. Okay. I'm again speaking. If any one of you has any doubt, please feel free to interrupt me in between and ask it. Okay. So because if you will have any doubt and that will perpetuate for the along the session, then it might be possible that you will not get the further things we are going to learn. So that is why I'm again and again asking you to please ask your doubts.
So like every layer just accepts some data and rejects some of the data that is transmitted from the previous layer.
Yeah, definitely. That is what a layer does. It takes some data as an input, performs some calculation. By calculation, I mean it is extracting some information from that input data. Then that data is provided onto the next layer. That's the thing. Like that is what happens in each layer. Also, like if we don't see it layer by layer, if we see it by neuron, that is the thing. What is happening in each neuron? It takes some input, performs some calculation, extracts some information. That extracted information is given as an output to the next neuron or into the next layer. Okay. Understood?
Yes, sir.
So yeah. Now let's see. Now let's move forward on to the next slide. So now we have come to activation functions. What are activation functions? As I told you, each neuron takes some input, then performs some calculation, extracts information, and gives that as an output to the next layer. So let me show you one more thing before that. If you see in this example, where my pointer is, some neurons or basically some black dots are connected with the next layer via this blue line, right? But some are not connected. Can you see that? For example, this dot is sharing the information with the next layer, but this dot is not sharing the information with the next layer. Can you see this?
Yes.
So that is where activation functions come into play. What activation function is basically, activation functions tell the neuron if they have to share the information they have extracted to the next layer or not. Because the thing is, whenever we give an input to a neuron, it performs some calculation, it will extract some data. But the thing is, the data or the information or the features which that neuron has extracted, it might be possible that is not useful for the prediction purpose. It might be possible like that may result in wrong prediction. That might be not as useful as some other information. Getting that point? For example, if we have 100 neurons, so it is possible 8 to 10 of them might be extracting some information which is not relevant or which is not useful or which might act as a noise. resulting in bad performance of our model. Okay, so that's where activation functions come into play. Activation function basically tells a neuron to basically tells the amount of information which it has to transfer to the next neuron or to the next layer. For example, suppose just a second. For example, this neuron has extracted some information. So what activation function is doing? It is telling how much information we have to like. Does it have to send it to the next layer or not? Okay. So there are some common activation functions like sigmoid and ReLU. Previously, like I am talking about around 1970s, 80s, or 1970, or 90s even. ReLU is a very new advanced activation function. Previously, sigmoid was the activation function which was popular and used. So first, let me tell you what sigmoid activation function is. Sigmoid is basically a function which squishes the output between 0 and 1. By squishing, I mean you give, for example, as you can see the equation, you put any value of x from negative infinity to infinity, but the output you will get will always be between 0 and 1. So that's the thing sigmoid does. Okay. Then, if we talk about ReLU, ReLU stands for rectified linear unit. It is a very advanced activation function, and when ReLU came, it was kind of a revolution because ReLU activation function mostly performs very well. I said mostly because there are some conditions where ReLU also fails, so that is why we have to check. But ReLU, what ReLU does is, if you provide any input that is any negative value, basically less than 0, then it will return 0 value for that. The output will be 0. But if you provide any positive value, it will return the same value as the output. So this is what ReLU activation function does. So you might feel that this is getting a little more advanced, mathematical or complex. But the thing is, deep learning or machine learning even is just pure statistics and mathematics at its base. In each single neuron, what happens is just some mathematical calculations, and based on those mathematical calculations, it extracts some information from the data, then runs an activation function to basically know how much information do I have to send to the next layer or to the next neuron. Okay, so this is what activation functions do. Till this point, is everything clear? If any one of you have any doubt, please ask. Okay, I'll take the silence as a no. So now let's see some examples of basically what does an activation function do. For example, if I give a particular input to an activation function, activation function basically acts as a threshold. For example, if that condition is met, then the output will be given to the next neuron, or the process of giving the output to the next neuron is known as activation of neuron. For example, if a neuron is activated, that means it is giving the information it extracted to the next neuron. It might vary that how the amount of information which is given, but activation basically means if the neuron has to give the extracted information to the next neuron. For example, if the when we on the input we run the activation function, if it is above some threshold, then neuron will be activated. Otherwise, it will not be activated. For example, if our activation function is less than 10, so input is 5, it satisfies the condition, neuron will be activated. This is a very simple example of activation function, just to make you guys understand what is happening. For example, this might also be an activation function, like this is an image input or pixelated input. The activation function is if the image has a curve. If it doesn't, so neuron will not be activated. Okay. You can also create your own activation functions, but actually it might seem like an easy job, but when solving a real world problem, it is not possible to create because in real life the activation functions we use are typically a bit very complex. So that is the reason there are some set activation functions, but definitely you can create your own activation functions as well. For example, here the activation it is the image of a image of digit 6. The activation function is, does it have a curve? So basically by curve we can you can imagine here it has a closed shape or something, because in real life the image 6 the digit 6 has a curve, so the neuron will be activated and it will send the information to the next layer. Now, so this is almost like a demonstration, again a demonstration of a neural network. The image of puppy you see here will be our input. And this model is basically telling the breed of the dog. And as we can see, there are two hidden layers. So, can any one of you tell what these lines are basically denoting? Like what this line denotes? As you can see, some lines are thick, some lines are thin. So, what do these lines denote? Anyone?
The number of neurons as per the density.
No, Swati. Actually, these are the neurons. For example, if
Connection.
this is our first layer, so this is our first neuron, this is our second neuron, this is third neuron, and and in the next layer there are four neurons. So these neurons are individually connected by some lines. So I'm asking, what do these lines indicate? Yes, Ayush, go
Sir,
ahead.
Amount of information,
Yeah.
Sir, relation between them.
Represent the
closeness
part of
between them.
Connection between
Can
the
you repeat
things
one
that it
by
can
one?
assemble.
Sorry. Can you repeat?
Connection between the things that it can assemble.
Connection between the things that it can assemble. Can you please
It's a copy. It can be.
can you please elaborate? Like, can you please explain what we are trying to say here?
The number of conditions met for transferring from one neural network to another, one neuron to other.
Yeah, so actually, what these lines are indicating is, as I told you, what each neuron does is take some input, perform some calculation, extract some information, and then that extracted information is sent to the next layer or to some neuron in the next layer. So, but as I told you, the thing is, sometimes all of that information is not being shared with the next neuron. Sometimes, maybe, for example, here we have multiple neurons, and as you can see, the top neurons have thicker lines as compared to the bottom ones. So it might be possible that the neurons at the top are extracting information which is more useful as compared to the bottom ones. So the thickness of this line basically denotes the weights. Now, what are weights? Weights basically denote how much information do we have to share with the next neuron. For example, as you can see, the first neuron is detecting a face of a dog. And if we come to the bottom, for example, if you can see here, this green one, fourth one from the bottom, this is showing some green part, like most probably it is detecting grass. So the thing is, since this neuron is contributing more towards the output, basically what we want to get. So that is why the weight of this neuron is high, which means the information that this neuron is capturing or extracting is being sent to the next layer more than the information which this neuron is sending. So that's what these lines are denoting: the amount of information being sent to the next layer, and which is known as weights. So basically, in each neuron, we assign some weights, and according to the weights, the amount of information is being sent to the next layer. Is this clear?
So we predefine the function of every
Yes,
neuron
sir.
beforehand.
Nikhil, can you please repeat?
So like we
Whoever.
assign the functions of the neurons like beforehand. What
Actually,
we
yeah,
do.
let me tell you that. So basically, if you remember yesterday's session, we saw there were 5 to 6 steps in the process of machine learning. And do you remember there was a backward arrow from the last step to the third step? Like after testing the model, evaluating, we again had an arrow which to the data collection step.
Yeah.
Can you tell why that arrow was present?
Like before, like if we like to reevaluate our data. So like if we are giving output like how much correct it is, like, according we get more data. Like if it like then we like do the things accordingly.
Yeah. So basically, that showed the iterative nature of machine learning or deep learning algorithms. So basically, when you get some wrong output, when you face some outliers on which our model is not predicting well or not working well, so then we also add those examples, those data points to our data set, and then again train our machine learning model so that it can learn on them as well, right? So basically, that's what happens in neural networks also. Whenever, as you were asking, like do we need to set the weights initially, right? And set activation functions initially. Activation functions, yes, are set initially by us, but weights are basically there are some techniques to initialize the weights, but in each iteration, each process, so basically we have to train the model. When training the model in each iteration, when going from the input layer through the hidden layers to the output layer, after we run our model once on a set of images, we calculate the error. Like, was our model able to predict well, or how much was the error? We basically calculate some error. Then that error is again propagated back into the neural network. And then suppose, for example, this dog is a Labrador Retriever. But suppose if our model is not trained well or on some very less set of images, maybe it produced the output. Just a second. It predicted the output as beagle. So then, what during the training step only, what would happen is the error would be propagated back to the last layer, then to the second last layer, then to the layer before that, till the to the input layer, till our neural network, till the error gets reaches to a minimum. And when to basically minimize that error, what is happening is tuning of weights. Basically, in each every step, weights are being customized or updated in such a way to improve the prediction in the next step. For example, if our output was wrong, it would the last layer would send like this was the error value, and it would tell the neurons in the previous layer, see, the output was wrong, so please tweak your weights in such a way so that the output would get better or the error would decrease. So when training the machine learning or deep learning model, every time our model predicts a wrong value, or basically whenever our model does a prediction, there is an error value associated with it. That error value is propagated backwards, and then model again and again for a single neuron in every layer, weights are being updated. Weights are what? Basically the amount of information we are sending from one layer to the next layer. So weights are being updated in such a way that our prediction improves, error improves. So initially, yes, we have to set weights. They are generally randomized, and there are some algorithms for weight initialization, but that is a very advanced topic, so we cannot cover this in this session. But yes, weights have to be set initially, but over the process of training, during training, those weights are updated again and again in every step. Is that clear?
So like we write algorithms to use the statistics to correct the errors.
Actually, we use some formulas to calculate the error. Then that when we propagate that error back, again we train our model to change the weights. Yes, for changing of weights, for updation of weights, there are some mathematical equations at play. For example, like probably you can discuss with me after the session. It would be better. Otherwise, it would take a lot of time. But basically, there are some algorithms like gradient descent, optimization algorithms, which are used for basically the weight updation and reaching to and like minimizing the error. For that, we have some algorithms and some methods. So you can discuss with me after this session, or you can connect with me on LinkedIn. I will be happy to answer your doubt there. Okay.
Okay, thank you, sir.
Yeah. So now let's move to the next slide. So now you know how this image recognition is working, like what is happening in the backend. Whenever you like yesterday, all of you guys tried the smart camera app, and you were able to like that was able to recognize the objects in your video. So that is what happens when you when that frame like whenever you are using the smart camera app, each and every frame is being sent over to the machine learning pipeline from the in the Google servers, and a deep learning model is being run on them. So that deep learning model takes that frame, finds each layer, extracts some information, and then since it is trained on multiple classes of objects, so then it tries to match like which object is more close to it. For example, if you take photo of a bottle or something, and bottle is one of the classes on which that deep learning model was trained, so it will try to match is the input I am getting close to a bottle, so then it will predict that it is a bottle. So these are the steps which were happening in the backend in that model. There are multiple layers. Each layer has some neurons. Those neurons are extracting the data, giving it to the next layer, and finally the output layer gives us the prediction. And this happens although it takes too much time to train a model, but yes, after training you can almost run the model in real time if the model is optimized.
We train the model till the error percentage is zero, like till it's perfect. So number of errors found. Do we train it to that extent, or do we leave it at 95%? If it's 95% true, then it's okay.
Okay, so the thing is, you have to set a threshold, right? Whenever you are training a machine learning model or a deep learning model, you have to set a threshold. That threshold is based on your goal, what outcome you are trying to achieve. That might be based on accuracy, that might be based on loss. That I want my loss to be at this level, it should not cross above that. Or accuracy, I need 95% accuracy. Until the model reaches 95% accuracy, I will be training my model. So that is the thing. But definitely because it is a very complex process, the training of a model is a very complex process, computationally intensive. So after a certain point, law of diminishing returns comes into play. So definitely you would have to set your goals in such a way so that, like, basically you have to strike a balance between the accuracy or the goals you want to get and the computation power you want to like put, because production level models sometimes are trained on a very huge amount of data, and they take many days into for just training part. So that is why you have to set a threshold, a goal, like this will be my threshold, and till this point I will be training my model. Okay.
Okay, thank you so much.
Okay, so now let's move on to the next slide. Yeah, so as in the beginning I told you guys, today's session will be a bit more interactive and interesting. So we will jump onto that, but wait for a few more slides. So basically this is a snapshot from the Tensorflow Playground site by Google. There are some things which you can notice. Here you can visualize how a neural network is getting trained in real time. You set the inputs based on a particular first of all, as I mentioned in the yesterday session, the first step, whenever we solve something by machine learning or deep learning, the first step is to visualize our goal. What are we trying to achieve? So in this side, we are given an output. To achieve that output, we set the input we give. So features are basically our inputs. Then there are some hidden layers, and then those all are connected via weights. The amount of weight information you want to send to the next layer. There are also some hyperparameters, but hyperparameters are basically more of a somewhat advanced thing, so that will not be covered in this video. So now let's move forward towards this thing. So as you can see, this is the output we are trying to achieve. The output, by output I mean this is our data. We have two classes. We have orange bubbles and blue bubbles. So we have to separate them via a deep learning model. So this is the output we are trying to achieve. Here you can see we have some features like x1, x2, x1 square, x2 square, and further. You can choose what features you want to provide. Then here we have our hidden layers. You can choose the number of layers you want to set in your model, how many neurons each layer should have, and like so. So this is the link for the TensorFlow Playground. Shubhankar, if you can please share the link in chat so that the attendees can check this out on their side. Yeah, that's the link. Can you guys please open the link? The link just sent in chat. When you open, you will see some tasks there. So first you have to perform task 1 to 3. The tasks are specified, like what you have to do in each task. Then try to run, like basically try to complete those tasks and then share your experience. When you are done, please raise your hands, and then we'll discuss them together. Whenever you guys are done, please raise your hands.
So I have a doubt. In the first task, it says that will it be able to, will this model learn any non-linearities? What does it mean by that?
Yeah, by non-linearity we mean, as you can see the data here, we have two groups of orange dots and two groups of blue dots. So by non-linearity we mean can you separate this via a straight line? Can you separate this data by using a straight line?
Okay.
Because as you can see, the above activation field is mentioned and it would be set to linear, right? So since we are using a linear activation, so our model will only be trying to separate this data using straight lines. So the question is, can we use straight line to separate this orange dots from blue dots?
So single straight line.
Yes. Even if you try to use multiple straight lines, then also you will not be able to do that perfectly.
Sir, to even separate them 100%, it is not even possible because some of the blue and orange dots are combining, overlapping each other.
Yes, definitely. That's the point I wanted you guys to observe. So, did you guys try to train the model? Over the top, you can see there's a play button, and when you click on that, the model will start training. So, did you guys try that?
Yes, sir.
Okay. So, basically, just a second, let me open it on my side as well. Yeah. So as you can see, when the activation is set to linear, even if I try, see, I can add more neurons from here. I can add multiple layers from here. Now, even if I try to train the model, it is not able to separate the data, orange dots from blue dots, right? But the thing is, if I change my activation to, let's say, ReLU, because you guys just saw what ReLU is doing. Basically, whenever it gets a negative output, it returns 0. Whenever it gets positive input, it returns that same input. So now, as you can see, after I set ReLU as my activation function, the model is able to, and also after adding one more hidden layer, the model is able to separate orange dots from blue dots pretty like better than what the linear model was able to do, right?
Yes, sir.
And over here you can see the loss. For example, let me move back to the linear model. And even if I'm training, so here there's a term called epochs. Epochs basically suggests the number of times you are moving over the data set. Basically, the number of times you are again and again training using that data to train your model. By training, I mean updating the weights, tweaking our model to better fit that data. Okay, so as you see, I trained it for 707 epochs. That means 707 times this this data is basically fed into the model, and it updated its weights, and then it has reached a position where it is trying to separate the model like this. As you can see here, the loss is almost 0.5. When I change it to ReLU, train the model again, as you can see, the loss has decreased to 0.2. So basically, I also want you guys to notice one more thing here. Let me run this again. As you can see, if I try to run this model again and again, as you can see, the lines, basically the separating lines, the model is getting trained a little bit differently each time. Initially, the first time I basically showed you it, the model was better, better than this one, right? If I train it again, then let's see, it starts off with some kind of different orientation, and this time, as you can see, it is not even able to separate that, separate the data points. So this shows that how machine learning algorithms are different from the traditional programming algorithms, because they always have a fixed output. Because they have a set logic, we give a particular input. For example, if you are writing a sorting algorithm, so it will always sort the same way, right? It will always follow the same process to reach that output, and that output is also always just one. There is a fixed output. Uh, Generally, the problems we try to solve with rule-based programming basically have fixed output. But when we use machine learning, our output is basically not set. It is deterministic or probabilistic, I would say. So also the steps we use, the steps we perform to train our model to reach that output are also different. Because, for example, let's see. Here we have two hidden layers. The first layer with 3 neurons, the second layer with 2 neurons. So as you can see, if I try to train the model again and again, try to notice the shape inside all of these neurons, you will see that there is a different shape every time. Also, as you can see, some lines are thick here, some lines are thin. So these weights are also different every time. So what this shows is, whenever you are basically trying to train a deep learning model, the steps it is using, we don't know what steps it is using to train the model. They can be different every time, but uh, generally they reach to a common output. I would not say same output, but generally they all after a particular amount of time, they all reach to a similar output, I would say. So if I try to train this again, now let's see, as you can see, it is training a bit differently. So this shows how machine learning algorithms are different from traditional algorithms. As you can see, previously this node, this neuron in the second hidden layer had a different shape. It didn't like its output was not as its output was not basically fed into basically this didn't have any uh, extracted information which was used to predict the output. But this time, as you can see, there's a some information is being used. If I train this again, now you can see. Let's wait for at least 500 epochs. Because the performance will be stable then, yeah. So now you can see the shapes, the amount of information being used and provided onto the next layer for predicting the output is different each time. So this shows the nature of machine learning algorithms is very different from the traditional algorithms, because each time it might follow some different steps to reach a different output. For example, previously like 2 steps before that, I was able to separate this data, but now as you can see, the model is not able to separate this data. So that is the reason we have to do some kind of trial and error, changing the hyperparameters. By hyperparameters, I mean learning rate, activation function, regularization rate. These are some more advanced topics, not for today basically, but definitely in further sessions you will be able to, like, we'll be guiding you what those are. But for today, the main idea, the main goal is to get you the intuition behind how machine learning algorithms work. And this is the perfect example, because this shows you visually, you can see how a machine learning algorithm is solving a problem. Because the problem is separate orange dots from blue dots, and these are our inputs x1 and x2. So this first neuron is just using this much amount of information. And this one is using this much amount of information. The next layer neurons are using this way. So combining all of this information in, like, basically joining the pieces together. Some neuron is giving some data, some other neuron is providing some other information, and then joining it based on weights. As you can see, these two, this line is thicker than this one, and this line is thicker than this one. So basically, these neurons have more weightage than this top one. So this is how each time, if you will see, the weights will also be different. So as you can see, just before this, there was some weight initialized to there was some weight for this neuron as well for the x1 data point, but this time there's no weight. So which means that x1 no information is given to this neuron. So basically each time the way of training, the way of reaching the output of a machine learning algorithm is very different from the traditional rule based programming. Now if I move to like next slide, you will see, let me scroll here only. So now you have to perform these two tasks. This will show you how initialization has a very big role to play during the training and reaching the output in neural networks. So if you see, what they are saying here is, before each trial, reset the network button to get a new random initialization. A reset. This is basically the reset button. So as you can see on the right hand side here in the output, whenever I'm clicking on reset, this basically shows initialization. As somebody of you mentioned, I think Nikhil mentioned, do we have to set weights initially on our own? So yes, we need to set some weights initially on our own. Generally, there are some algorithms for that, or we can set them randomly. But this is showing that each time if you press this button, weight initialization is different. What is weight initialization? These lines are weights. The amount of information given to this neuron is what that weight denotes. So basically, like if you see, if I click on this reset button, these weights are getting changed. How much information do this neuron has to give to the next neuron? So as you can see here, the weights are getting changed. And now if I, just a second, let me add one more layer. Now if I try to basically run this model, as I showed you, if I try to run again, every time the weights are different, the output is different. So that weight initialization also has a major role to play in the training of neural network. As we saw in the above example, sometimes the neural network was not even able to separate the data. So that is why weight initialization can play a big role in the performance of our neural network. So definitely there are algorithms for that, but it would be a bit more advanced for this session. So let's leave it for further sessions. Any doubt till now? Yeah.
Can I ask something?
Yeah, definitely.
If we increase the number of hidden layers, then would the efficiency increase or like the test loss decrease? Would it
Yes.
matter?
Yeah, definitely. That's a very good point, Dhriti. If I try to increase the number of hidden layers, or basically the number of layers or number of neurons in a particular layer. So generally, whenever you by increasing the number of neurons or by increasing the number of layers, you are making the model more complex. And when you make the model more complex, it can help in solving even more complex problems, or it can help the machine learning, or it can help the deep learning model to gain more insights from the data, to gain more basically to gain more extract more information from the data. But like let me show you. For example, now our model is performing well. Even if I reset it again and again, it is pretty much able to separate the data points. But sometimes what happens is, if I overdo this, I'm not sure if we'll be able to visualize this. For example, I have added 4 layers and many neurons. Sometimes what happens is uh, the model becomes so much complex that it overtrains to a particular data. That phenomena is known as overfitting, but I cannot go into detail as this is more of a beginner session. You can definitely contact me or on LinkedIn. I'll get your doubts cleared there. But sometimes by increasing the number of layers, by making our model too complex, what happens is in real world data, always some noise, some or the other noise is present. So when our model is very complex, it even learns on that noise. So when that is not good for a deep learning model, because if when you will be testing that model on some new data, then it might be possible it will not perform as good, because it was too much trained on that training data that for example, if you read one book again and again, you will master that. But if I, for example, you are reading a computer science book only, or a particular subject. For example, if you are reading an object-oriented programming book, you will master that subject, whatever the content is present in that book. But for example, if someone asks you a question which was, or a type of question which was not present in that book, then you might get a little bit confused. So that is that's what happens with deep learning models also. When you make the model too much complex, it overtrains on that particular data, and it might not be able to perform that well on testing data. If you still have some doubt, then please contact me after the session. I will be happy to answer your doubt. Yeah, I think Divyansh has raised his hand. Do you have any doubt, Divyansh?
Yes, I want to ask something, but I want to ask it via an example. May I?
Yeah, definitely.
Sir, let's say I am the owner or the maker or the coder behind that image finder app. Okay, so
Yeah.
if I have to make, like, I have to make inputs. I make an input, for example, of a particular breed dog, like say bulldog. Okay, I formatted somehow. If someone draw a bulldog, then then my app will show him or her written in a bulldog, or let's say it will give a output of bulldog. But if in case the user draw some specs or some funny images of a bulldog having
Yes.
hat, having clothes, etc. So is it too early at a super beginner level like at me to dive into this much technicalities?
So basically, let me rephrase your question. Basically, what you are trying to ask here is, suppose you have created a dog classifier which tells if a dog is present or not, right? And if someone gives it a image in which a dog is wearing a hat, and basically there are some obstructions on that dog, right?
Yes,
Which
sir. And
can make difficult for that model to check if a dog
justify
is.
the answer. Yes, sir.
Yeah. So basically, yes, actually at a beginner level, I would say it might be a little bit too much to think about this. In the beginning, you can just try to train a few neural networks, and you can get into these things afterwards. But if I talk about production level machine learning algorithms or deep learning algorithms. For example, if you use Google Lens, or in yesterday's session, if you have tried to use that smart camera task in the Google Crowdsource app. So if you try the same thing with that model, it might be able to, even after those obstructions, it might be able to recognize that it is a dog. So the reason here is because, first thing, the data. Google gathers a huge amount of data. So their data set is so large that they almost cover all the possibilities. They have the images with obstructions, they have skewed images, they have rotated images. Although you can somehow tackle this situation by some algorithms, since there are some functions in, if you are using TensorFlow, there are some pre-built functions which tweak your data in such a way so that your model can be more generalized, and to basically improve its performance. But on a beginner level, I would say, since you don't have access to that much amount of data and you don't have resources to train the data. For example, there are state-of-the-art models like LeanNet, GoogleNet, AlexNet, other etc. So they are very complex models, and the data they are trained on almost has like all the possibilities which end up in a real world scenario. So that is the reason the production level models are able to perform well even after those obstructions. Definitely, you can do some more research how I can tackle these situations, how I can improve my model for this. One thing is definitely add more data, add some more examples which will help your model. But other than that, there are also some things you can do. As I mentioned, you can TensorFlow has some pre-built functions for skewing, rotating, and all of this. So you can try that. If you have some more doubt, if you want to ask how we can implement that, you can talk to me after the session, or you can connect with me on LinkedIn. But for this session, I think we'll stick to some basic models and how basically a deep learning model works.
Okay, sir. Thanks for your inputs.
Yeah. So now let's come to this last example on the TensorFlow Playground side. Basically, as it says, it's a neural net spiral. As you can see, the models are divided, the data points are in a spiral. For example, let me zoom in a bit. Yeah. So the blue points and the orange point are entangled in such a way that they are forming a spiral. So this example can be used, can demonstrate an area where even neural networks can find, like, basically face some problems in training. So let me try to run this, train this model. As you can see, it is facing many issues. Like it is not able to converge. By converge, I mean it is not able to minimize the error. As you can see, the loss is very high, right? And it is not able to shape. It is not able to find a function which can accurately predict on this data. Even if I try to make model a bit more complex, like if I add one more layer, one more neuron here and here. So as you can see, it is trying, but still it is not able to like perform well on this kind of data. So this is when feature engineering might come into action. By feature engineering, I mean, see, in the before we only had two features, x1 and x2. In this example also we had only two features, x1 and x2. But here we have access to some more features, like x1 square, x2 square, x1, x2, like product of x1, x2. X1 is basically one feature, x2 is basically the second feature. By feature, you can, for example, you can take as if you are building a dog classifier, eyes can be one feature, length, height of dog can be one feature, or color of dog can be another feature. So the by feature I mean some attributes of the data. So here we have access to some more features. Even if I try to, let's say, as input, I'm also giving x1 square and x2 square as an output as an input, and then I again try to train the model. As you can see, it is doing a little bit of a better job. It is trying to, as you can see, get this curve here. Let me add x1, x2 as well. Now let's try. So basically, it is trying to form that spiral to separate that data, but still it is not able to do that. And in many real world situations, real world data is messy. So sometimes even after being very complex, neural networks are very complex algorithms. Even after being so complex, they are not able to work well on real world problems or on some problems. Now let's try sine as well, like sine of x1 and sine of x2. So as you can see, it is trying well, but still it is not able to basically converge, or basically not able to predict the data points accurately. So this shows a situation where neural networks might also fail, and this also suggests like sometimes you may need to use feature engineering. For example, if you only have x1 and x2, then from your side you can show from your side you can perform some operations on those features, like basically product them or add them, or basically take a log or something, and in that way you can then tweak the input you are giving to the model. Sometimes, or I mean a lot of times, feature engineering helps, like changing what inputs you are giving instead of just changing your model. Also thinking about the input you are giving, because a machine learning or a deep learning model is like basically has a major role on the input. So that is the reason a machine learning engineer or data science person spends most of his time in the data phase, where they try to make the data more and more perfect for that model. Like you can clean the data, you can only give the features which are essential for the model, for which are essential and which are helpful for the deep learning model to reach the output. So that is why most of the time you have to spend is on features, because training the model is not, although it is very computationally intensive task, but it is not a very difficult task. The most difficult task in machine learning or deep learning is the data exploration phase, where you have to explore the data, you have to clean that data, process that data in some or the other way, so to make your model's performance better. Got my point?
Yes, sir.
Just a second. Let's move to our slides. Yeah, so basically these were the 3 exercises, and these were some points which I wanted you guys to understand. That neural networks, although being so complex algorithms, still they can fail on real world data, because real world data is messy. Now, yeah, Triti, go ahead.
We use the ReLU activation algorithm, so I also tried seeing the Sigmoid.
Yeah.
It was not even able to pull separate the blue and the orange dots if I use the Sigmoid. And in ReLU, it was working more efficiently. So maybe changing the algorithm, does that help?
Yes, definitely. Changing activation functions can also help. Activation function is also like all of these are basically hyperparameters. If you try to change those hyperparameters, like basically whenever you are training a machine learning or deep learning model, it is basically a game of trial and error. You have to try some values for those hyperparameters. You have to try multiple activation functions. You have to play with number of layers, number of neurons. Even after that, if that is still not working, you have to play with your data, clean it, pre-process it in some or the other way. So whenever you are building a machine learning or deep learning model, these steps are basically essential. Like you have to do a lot of trial and error. Then only you will be able to reach to a particular output. If you are using real world data, if you are using a very simple data, then deep learning models can like easily grasp the patterns and extract information and can easily predict the output. But when you are using large data sets, and as somebody mentioned that dog example, if that dog has some obstructions, if it has a hat or an glasses or something, then the model might get confused. So to cover all the real world irregularities or these messiness, you have, if you want to your deep learning model to perform well, then you have to do a lot of trial and error and play with your data a lot. So that is why maybe we can also like we can solve that spiral problem, but then we again have to try some different activation functions, or like we have to do some more trial and error, but definitely it can be solved. Yeah, so now let's see another example of a deep learning model in real time. Shubhankar, can you please share this teachable machine link in the chat? The second link I sent. Yeah, so please guys go to the recent link shared in chat. I am also opening it on my side. Just a second. Then click get started, and if I like teachable machine is a program by Google where Google has implemented or deployed its machine learning and deep learning algorithms for you to try. and these algorithms are basically optimized in such a way. These are not that much of a computation heavy algorithms. These are computation heavy, but even if you try to run them on your smartphones, so they run well. So these are a little bit lightweight models. For example, to just for showcasing here, if I open a image project, standard image model, and let's train a deep learning model in a few seconds. If I want to create a classifier, for example, I want to classify between a smartphone and I have a computer mouse here. So if I want to create a classifier model between the two. So as you know, the basic necessity of a deep learning or machine learning model is data. We have to feed in data on which it will get trained. So let me train the first class as my smartphone. Let me get out of the frame. That will help the model better. So if I hold this webcam button and just a second, I think I have to turn my video on here. Yeah. Yeah. So as you guys can see, I am recording some samples. I am taking some images here. Now, let me rename this class as smartphone, and the second class as mouse, and let me record samples here as well. So we have 77 images of the first class, 66 images of the second class. Now let me train the model. So although training a model is a very complex step, it takes little bit of a time. But here Google has optimized their algorithms in such a way, specifically on, just a second, I think, yeah, I think now it has started training. But Google has specifically on teachable machine, Google has optimized their algorithms in such a way so that even with very less amount of data, it can produce accurate results. For example, if I show my smartphone here, as you can see, it is showing that like it is detecting there's a smartphone, right? If I remove this and bring in my mouse, yeah, yeah. Now, as you guys can see, it is detecting mouse. So this is how this is a very basic demonstration of a deep learning model. Just a second. Still, it has some problems. Yeah, as you guys can see, if my face was there, then it had some problems. So because this model is trained on a very small set of data, that is the reason it is not able to perform that well, because deep learning models require a lot of data. Yeah, deep learning models require a lot of data to train, and 77 or 60 images is like nothing. If you will try to train, create a deep learning model on your own, then you will need at least like in thousands or lakhs of images to train it properly to cover all the scenarios. So you have to put some like basically you have to put some effort in finding the right data set, and then you have to move to the training of model step. Somebody is saying the link is not working. So the link is not opening, or like it is, has it freezed? Because if you record too many samples, then the site sometimes fails to respond. That might be the reason. So did you guys try it on your side as well? Just a second. The site is opening on my side. I have checked right now only. Let me share the link again, but like I think there's some problem on your side. Um, I checked the link right now only. I think there's some problem on your side. Are other students also facing the same issue? Are you able to open the site? Somebody please confirm.
Yes, sir.
Yes, sir. Sir, I was able to open this app.
Okay. So did you guys try to create some like basically you can also create rock paper scissors model also easily here. So you can try it out. You can try out that also. And since we are running short of time, you can definitely try to play with teachable machine after the session when or at your leisure. So basically now let's move on to the next slide. So this brings us to the end of the today's session. Yeah, Nikhil.
I'm so sorry, sir. I think that was a mistake.
Okay. So this brings us to the end of today's session. We saw in yesterday's session we summarized what ML was, what kinds of problem it solved, how was it different from traditional programming. In today's session, we dived a little bit deeper, and we saw what is basically we covered what were neural networks, what was deep learning, when to use neural networks. For example, as I told you, then we have even more complex problems like image classification. When you want to do face recognition, basically computer vision problems are typically a bit more complex in terms of like solving. So then deep learning models are used, for example, convolutional neural networks, which are specifically for image, generally used for specifically for image related tasks. So we saw when to use deep learning, how does deep learning model works. We went to the single processing unit, that is a neuron. What happens in the back end, how like when we give, for example, we are just giving an image as an input to the model. What kind of calculations does it perform? How it reaches to that output? We also what happens inside each layer visually on the TensorFlow Playground side. Then you saw an ready-to-use implementation of deep learning models on the teachable machine side. So the goal of these two sessions, basically the yesterday's introductory session and today's neural network session, was to get you guys first of all interested in the field of machine learning, to get you to basically tell you guys the products you are using every day, how they are working, because we use Google Lens every day, right? So now you know what, whenever you are clicking a photo, when Lens gives you like whenever it finds or makes a prediction on the objects present in the photo, you know what is happening, right? So other than that, this session, like these sessions will be carried forward by GDSC and Kratigence club as well. So this was all about these two sessions, the Explore ML sessions. Crowdsource by Google basically aims to gather a lot of data to make the Google machine learning algorithms better every day. For example, the Google Assistant receives a lot of new features. Google Lens receives a lot of new features. Even Google Photos categorizes your photos based on the things it finds, based on people. It groups all the photos of each and every person accordingly. So each service, almost all the services of Google you are using, some or the other way, there's some machine learning or deep learning models at play there. So now you know how those models work. I think these two sessions might have introduced some spark in your mind. these sessions might have got you interested towards the field of machine learning. This was the main goal with which I started. So now let's end today's session. Any one of you who have some kind of doubt, please feel free to ask them, or you can connect with me on LinkedIn as well. I'll be happy to answer your doubts there as well. Before I end the session, a post-workshop form has been shared in the chat. I request all of you guys to please fill that form, because if you don't fill that form, then you will not be receiving your ExploreML workshop certificates. Also, I would recommend you to fill that form now, because there's something you need to look for. I have opened the form here as well on my side. As you can see, after filling this first page, when you will move to the second page, here please select multiple facilitators, and please write my name, Rohan Sharma here, because then Crowdsource team will know like you guys are like basically my audience, so that it will help them evaluating my performance. After you fill this form, in some days, certificates will be rolled out to you by the Crowdsource team. So that's basically it. If any one of you has any doubt, just shoot it. Or if you guys have some feedback for me based on the content, anything. Yeah.
Sir, actually, when I was filling the form yesterday, it was asking which level of crowdsource I have to take.
Yeah.
Then I have to take level 1, level 2, or I am not a crowdsource user.
Yeah, so basically, you can fill the least level. Like basically, you don't have any knowledge of crowdsource. You can fill that. I think it was in pre-event form.
Yes, sir. Yesterday I have seen that form on MS Teams.
Yeah, so you can select the least, basically the lowest level there.
Also, I can take. I am not a user.
Yeah, definitely you can take, and you have to fill both the forms: the pre-workshop form which was shared before, and this post-workshop form now. Then only when you will fill both the forms, then only you will be eligible for the certificates. And if somebody has a doubt,
Yesterday's pre-workshop also, as we not attended yesterday's class.
Yeah.
Please share yesterday's
It might have been shared with the WhatsApp message. Just a second. Shubhankar, can you please share the pre-workshop form here as well? Just a second.
I have shared it in the chat.
Yes, sir. Thank you, sir.
Yeah, this was it. So guys, if you have any doubt, please feel free to ask, or otherwise we can end this session. Please fill both of these forms. I'm repeating again. Then only you will be eligible for the certificates. If you have any curiosity about machine learning, if you want to know how to get started into machine learning, then also you can connect with me on LinkedIn. No issues. If like anyone of you have a doubt, they can stay back. Otherwise, you guys can leave. Thank you for attending.
रुक जाओ.
It was nice having you there. Sorry.
रुक जाओ थोड़ा.
Excuse me, sir.